Hey, just in case if you're actually wondering why this was true in the first place, so yeah, you are in the right place with that. So yeah, most of us we know that let's say if a vector is defined as a1, a2, a3, right? Yeah, this is basically in I direction, z direction, k direction. Similarly, b vector is b1, b2, b3 in I direction, z direction, k direction. Then this is our dot product, right? This is our dot product a vector dot b vector, and this is our cross product, right? A vector cross b vector. And we have known that dot product is like if it's in component form we can do it this way, and if we have magnitude and angle we can definitely find like directly as well, right? Again, for the magnitude of a vector cross b vector, so yeah, this is actually for magnitude, so that's why this first line is for determinant and this second is for magnitude actually. Yeah, so yeah, if this determinant will give me cross product, and then if I take the magnitude, I will basically get a b sine theta, right? And in this video, like, we will just discuss and see why these two statements are true. And yeah, now I think we are good to begin. But before we begin, let us also discuss a few things about like magnitude of a vector, right? Because that will be helpful later on. Okay, so about magnitude, let us first start like how we can find the magnitude from 2D. So for let's say if I have a vector, let's say this is a vector, right? And this a vector is basically, let's say, it's defined as uh, for vector we basically give this arrow brackets a1 comma a2. That means this vector over here travels a1 distance in I direction. I means the normal x direction, and a2 distance in the z direction. So to find the magnitude basically means the length of vector, right? So yeah, to find the like this length of vector, so this length of vector, what I can do is I can use Pythagoras theorem, because definitely I and j they are perpendicular. Those directions are perpendicular. So I can find the magnitude of a vector by just square root of a1 square plus a2 square, right? Yeah. So here we see that like what I do for find the magnitude is just I take the squares and the sums of all the components and take a square root. This is true for 3D as well, right? This is true for 3D as well, and yeah, this is true for 3D as well. If I have a, let's say, this vector, let's say, uh, I will draw three components first. This is perpendicular basically, and this is I direction, and this is z direction, and this one is k direction. And now let's say I have this vector over here, and this vector is basically defined as this perpendicular a1 wait perpendicular a1 a2 a3, right? Now let me also draw the coordinate axis if you are having a hard time to like understand what's going on. Sorry. Okay, this is basically the x-axis. This is a y-axis. This is z-axis, right? So basically, this point over here is going this a1 units in x, and then in y it's going a2 units, and in z it's going a3 units, right? So and if you want to find, let's say, the length of this vector, the length of this line, the magnitude, what we can do is, first of all, you can try to find the length of this, like its projection in xy axis. First of all, you can find the length of the projection, in which we know that, okay, again we can use Pythagoras theorem. So this is just square root of a1 square plus a2 square, right? And again now if you look at this triangle, this is again a right angle triangle, right? So if you again you see that, notice that that's right angle triangle. Again you can use the same Pythagoras theorem. Uh, so our magnitude of a vector will just be square root of a1 square plus a2 square right? And then this square is actually not over here. This square root should be over here. Okay, a2 square plus a3 square, right? And now this is just a1 square plus a2 square plus a3 square. So you can definitely see the pattern, and though you cannot like do it for 45 geometrically, but yeah, even from the pattern, you might have noticed that how we should be defining the a vector, right? So even if now in 4D, if a vector was a1, a2, a3, a4, we will define the magnitude of a vector as just the square root of a1 square plus a2 square plus a3 square plus a4 square, and this is how the magnitude of vector is defined, right? So if I just try to uh, like square both sides, this will just be magnitude of a square is just a1 square plus a2 square plus a3 square plus a4 square. This idea of magnitude of vectors will be helpful later on, so I just introduced it at the beginning, and now let's go on proving these things. Now, first of all, we want to prove the dot product form this formula, and then again we will prove this one. But and while proving this, we'll again use this formula. So yeah, let's go with the dot product first. So for dot product, again before going dot product, we'll also need to know another fact, which is also called cosine rule. That will be helpful. Now, what cosine rule says is in a triangle, let's say I have an angle theta over here. Let's say these are A, B, C sides. Then if I want to find this A square, that will just be in this angle theta should just lie opposite to A, right? For this formula to work, like this theta should write opposite to A. So yeah, whatever the side is there in the left hand side, that should have the angle opposite to it. So in that case, the formula will be A square is equals to b square plus c square minus 2bc cos theta. And notice that theta is just opposite to a. Now, yeah, now if you want to prove this formula, I guess what you can do is like it would not be that hard, I guess. Okay, so this is our theta, right? Now you can probably make a triangle over here. We have A, B. You have this whole side is C, right? Now maybe you can make this as x and you can make it c minus x, right? Okay, now what you can probably do is um okay, so let me do a slight change. Let me say that this is x and this is c minus x. Now what I'm thinking to do is I know that x is just b cos theta, right? X is just b cos theta. We will use this fact later on, and for now what we can do is we know that I can find this as in two ways, right? I can find this as in two ways, either by just doing square root of a square plus c minus x square, and another idea is just square root of b square plus x square, right? So now if I just square both sides, this will be a square plus c minus x square is just b square plus x square, right? And now I know that x is just b cos theta. So a square plus c minus b cos theta is square is equals to b square plus b square cos square theta. Now since this expression is only in terms of a, b and c, definitely we will get the required expression. I'm pretty sure about that. So let's still do it. This is a square plus c square minus 2bc cos theta is equals to b square cos square theta is equals to b square plus b square, yeah, b square plus b square cos square theta. Now this cancels out, so I have did I get the required expression? I think I got something different. I got b square is equals to a square plus c square minus 2bc cos theta. How can that happen? Wait, let me see. Okay, square root of, oh wait, man, sorry. No, this formula is not true. This should be minus over here. I'm sorry. There should be minus over here. Okay, so I'm sorry about that. Yeah, because I guess you know the Pythagoras theorem, right? In Pythagoras theorem, if you have as p b, h square is equals to p square plus b square, right? Okay. So yeah, now, okay. So again, let's redo this. Let's redo it. Okay, so this is a square minus c minus x square is equals to b square. Okay. Now we know that x is just b cos theta, so c minus b cos theta square is equals to square root of b square minus b square cos square theta, right? Now if you square both sides, this will just be a square minus, this will just be c square minus 2bc cos theta plus b square cos square theta, right? And this will be equals to b square minus b square cos square theta. And this is a square minus c square plus 2bc cos theta minus b square cos square theta is equals to b square minus b square cos square theta. I can cancel this out, so I get a square is equals to b square plus c square minus 2bc cos theta. So this is it, right? Okay, so I have proved this, and this will be helpful later on. Okay, so now that we have this true cosine rule and the magnitude thing in place, now I guess we are good to begin. So yeah, now okay, so now to prove this, like, okay, I need to make an angle, right? Because I need to involve angle in Parent's formula. So first of all, let me like try to see how I can get an angle over here. So let's say this is our a vector, this is our b vector, right? Or let me interesting. Let's say this is our a vector or this is our b vector. Now in that case, if this is a vector, this is b vector. Now a vector minus b vector will basically go from b to a, right? This is a vector minus b vector. And normally people ask you to see it as b vector being added with a vector minus b vector. That also helps, because if you add these two, b cancels out, you get a, which is basically what it's here over here. So yeah, so either way you can understand that. Now so yeah, so we will use this. Now we know that this angle is theta, right? So we will use this like setup to find the value for theta, and yeah, we'll use some vector things. Okay, now first of all, let me just get a normal triangle associated with this figure so that I can use this cosine rule. So you think if it's normal triangle, that this side will just be magnitude of a vector and this side will just magnitude of b vector, and if this is theta, this will just be uh, um, a vector minus b vector, its magnitude, right? Okay, now okay, now if I use the cosine rule over here, that will say that basically first the side opposite to angle is this side, right? So I will have that over here, and this square will just be a square, this b square, a square plus b square minus 2 a b cos theta, right? Now how do you find this one? How do you simplify that expression? That can be a problem. Now for that, notice how dot product is defined. Dot product is defined as the product of the first with first, second with second, third with third, right? Now let's say if I had a vector as a1, a2, a3, and again next is also a vector as a1, a2, a3. You might notice that if I dot a with a, what I will get is I will just get a1 is times a1 square plus a2 square plus a3 square, and this is just the magnitude squared, right? For this one, if I just square the magnitude, I will get a1 square plus a2 square plus a3 square, and this is an important connection between dot product and the magnitude of the vector. So this is just magnitude of a being squared. So this is an important idea, that if we dot a with a, this is just magnitude of a squared. So we'll use that over here to simplify this expression. Over here, to find this magnitude of a vector minus b vector square, we will just dot a vector minus b vector with and we'll just dot a vector minus b vector. Sorry again. How do I delete this now? Okay. Okay, we'll just dot this vector with this again. We just proved that, right? And now we know that this is just magnitude of a squared plus magnitude of b squared minus 2 magnitude of a magnitude of b cos theta, right? This is just from the cosine rule. This a square is equal to b square plus c square minus 2bc cos theta. Okay, now I guess you guys know that this dot product is basically associative, distributive, and all of that. It satisfies all of those properties, right? And yeah, you can verify that, or you can also watch like Khan Academy videos or any videos on YouTube. Because if I go on proving that like dot product does satisfy those distributive and such properties, it will take a lot of time. Okay, so yeah, so I'll just basically use it, and if I use that, I can basically first of all just multiply by a vector and then multiply a b vector, right? So I'm just using those properties that dot product satisfies. So this will just be magnitude of a vector square plus magnitude of b vector square minus 2 magnitude of a magnitude of b cos theta, right? Now again, now over here I can see that it's just, again, if I try to distribute it, this will just be a vector dot a vector minus a vector dot b vector minus b vector dot a vector minus b vector dot a vector, right? So this is dot dot dot. Okay, magnitude of a squared magnitude of b squared minus 2 magnitude of a magnitude of b cos theta. Now again, we already learned that magnitude of a like dot with itself is just magnitude of a squared, right? This is, and now again we know that dot product is commutative, so a vector dot b vector is same as b vector dot a vector. So using that, this will just be negative 2 times a vector dot b vector because both are same. And now again, b vector dot b vector is just the magnitude of, wait, there's two negative signs, so this will be plus, so plus magnitude of b squared. Now yeah, we have this expression. Now what you can do is I can just cancel the magnitude of a square magnitude of b square, right? So what's left is just negative 2 times a vector dot b vector is equals to negative 2 magnitude of a vector magnitude of b vector cos theta. I can just cancel the negative sign from both sides, 2 from both sides. So you see, I get the required expression that a vector dot b vector is just magnitude of a magnitude of b cos theta. And that proves the statement. And this proves the statement, right? Okay. Now finally we have proved, like using magnitude formula, the cosine rule, and this stops that the dot product is magnitude of a magnitude of b cos theta, right? Now if we have this, now this will not be too hard. Okay, now let's go to cross product. So just like how dot product is defined this way, and we showed that that's just equivalent to the other formula. Now cross product is defined this way, and we will show that this is equivalent to the other formula. So yeah, first of all, let's evaluate that expression so that we can prove that LHS is in fact equals to RHS, right? So yeah, like if and the reason I'm taking the magnitude is because a vector cross b vector basically gives vector, right? Vector which is perpendicular to both a and b. Let's say that be n vector, so that it just gives direction, but the magnitude is just one. So yeah, let n vector be a unit vector that gives the direction of a vector cross b vector, and this will basically be the magnitude. This will be the magnitude, right? So now for now we will just try to prove that the magnitude is given by AB sine theta. So let's see how we do that. First of all, we know that to find the A vector cross B vector, we need to use the determinant, right? So yeah, let's do that. A vector cross B vector can be found from determinant. I is a k. This is A1, A2, A3, B1, B2, B3, right? Now its determinant would just be first of all I times a2 b3 minus b2 a3. Now negative j. I guess you guys know how to find determinant. A1 b3 minus b1 a3 plus k a1 b2 minus b1 a2. Right, so let me write it in a proper way. That means what I want to do is I just want to remove the negative sign over here, though that doesn't matter anyway, but still 3 minus a1 b3 plus k times a1 b2 minus b1 a2. Okay, so now that we have it as the cross product, now let's try to find the magnitude of cross product. And yeah, let's now this also square the magnitude, because I don't want that long like square root sign. So magnitude of a vector cross b vector, and then we will square that so as to not have this square root sign. That will just be a2 b3 minus b2 a3 squared plus b1 a3 minus a1 b3 squared plus a1 b2 minus b1 a2 squared, right? Now magnitude of a vector cross b vector squared will just be, we know that this is just a2 squared b3 squared. First of all, let me just write all the square terms, and then I will write the minus 2ab terms, plus this is b2 square a3 square plus b1 square a3 square plus a1 square b3 square plus a1 square b2 square plus b1 square a2 square, and minus 2ab terms now, minus 2 a2 b2 a3 b3 minus 2 a1 b1 a3 b3 minus 2 a1 b1 a2 b2. Right, now we get this expression. Now over here, this negative 2a1 2b, these things that are over here, like what we want to simplify this expression right now. If you wanna prove like this other thing, definitely we need to simplify this. And like these negative expressions, uh, like what I can do is, if I just take the dot product and if I square them, if I just square the dot product as well, I will definitely get those two a1 b1 a2 b2 2 a2 b2 a3 b3, which cancel with it, right? And that gives some hope of simplification. So yeah, let's try that. No, there's entire possibility that it would not work, but there's some hope, right? If I just take the dot product and then square it, so yeah, if that might work. So let's try to do that and then add those two and see if there's anything like beneficial or not. So if we take the square of the dot product, that would just be a1 b1 plus a2 b2 plus a3 b3 squared, which will be a1 square b1 square plus yeah. Now I guess you guys know the formula for squaring trinomials, right? So basically, if I have a plus b plus c squared, that would just be a square plus b square plus c square plus 2ab plus 2bc plus 2ac. Please know that. Please know this formula. This will be helpful. Okay. So this will be a1 square b1 square plus a2 square b2 square plus a3 square b3 square plus 2 a1 b1 a2 b2 plus 2 a2 b2 a3 b3 plus 2 a3 b3 a1 b1, right? Now if you just try to add these two expressions, a vector cross b vector square plus a vector dot b vector square, what you will get is this thing should exactly cancel out. If you add this 2a1 b1 a2 b2 would cancel with this one, this would cancel with this one, and sorry, this 2 a2 b2 a3 b3 would cancel with this one, and a3 b3 a1 b1 cancel with this one. So what we get is the rest expressions, and those expressions will have some like symmetry in them. a2 square b3 square plus b2 square a3 square plus b1 square a3 square plus a1 square b3 square plus a1 square b2 square plus b1 square a2 square plus a1 square b1 square plus, so this is from the cross product, and now from dot product we a1 square b1 square a2 square b2 square plus a3 square b3 square. Now let's say if you want to take a1 square common, I will get b3 square plus b2 square plus b1 square. Again, if I take a2 square common, I will get b3 square plus b2 square plus, wow, I think there is some mistake. Mm, because mm, oh sorry, there's no mistake. Yeah, so there's also b1 square. So b1 square plus with a1 with a now with a3 square, that's just b2 square plus b1 square plus b3 square, right? Now if you again take b1 square plus b2 square plus b3 square common, if you take that common, what we will get is a1 square plus a2 square plus a3 square, right? And now we know that this is just magnitude of b vector square, and that's just magnitude of a vector squared, right? So this is this is the interesting expression actually. A vector cross b vector square plus a vector dotted with b vector square is this thing. And now we already know that a vector dot b vector is just magnitude of a magnitude of b cos theta, right? So this will be a vector cross b vector magnitude square plus this will just be, so magnitude of a magnitude of b cos theta, so magnitude of a square magnitude of b square cos square theta, right? That would just be magnitude of a square magnitude of b square. Okay, now if you take this to other side, a vector cross b vector square will just be, if I take magnitude of a vector square magnitude of b vector square minus magnitude of a vector square magnitude of b vector square cos square theta. Now this would just be, if I take magnitude of a vector square magnitude of b vector square common, 1 minus cos square theta, and guys, that's where we see how it's being proved. So yeah, this is just magnitude of a vector square magnitude of b vector square times sine square theta. Now if you take positive square root in both sides, if you take positive square root in both sides, we will get a vector cross b vector is just magnitude of a, its magnitude is just magnitude of a magnitude of b sine theta, and that's how it's proved. So yeah, it's proved, right? Now let me just tell a little bit about this new formulas, how they help us interpret the cross and dot product geometrically. I guess you got the proof. This was definitely long, but this was not hard, I guess. So yeah, now if I, now if we have this, now we can make some interpretations about this new formulas. So yeah, now if I have like a vector and b vector like this, and this theta, what dot product gives us is product of the magnitude of a times magnitude of b cos theta, right? And we know that if I find b cos theta, that would just be the projection, right? This projection over here, and this is a, this projection is b cos theta. So yeah, so this is just ab cos theta, which gives us the product of the a vector with the projection of another vector. So that's how it's uh, mm, that's how it's interpreted geometrically. For the next one, if this is a vector, this is b vector, right? This magnitude of a vector cross b vector, ab sine theta, just gives us this. This is theta. Since b sine theta is just this height as, so if I multiply a with as, I will just get the area of this parallelogram with b vector being extended to this side. This is just b vector again, this is a vector again, because b sine theta is as, because as is just b sine theta, so ab sine theta just gives the area of parallelogram. So yeah, the magnitude of cross product is interpreted as area of parallelogram, and AB cos theta is just interpreted as a vector times the projection of another. So yeah, I guess these proofs were helpful for you to get some new insights. I guess you definitely enjoyed this cosine rule and all these vector stuffs. So hope it was helpful. If you think that like some of your friends or juniors like need this, please do share. Thanks for watching and look forward to seeing you in the upcoming videos too.